Speech Pitch by Iska Sak.
Hello there, and welcome back to Speech Pitch by Iska Sak. I'm Priyanshi.
And I'm Kay Berkling. We're here together with
Hynek and Morgan Nelson Morgan. For our audience, Hynek Hermansky is a professor and founder of the Center for Language and Speech Processing at Johns Hopkins University. Some of his most widely known work includes perceptual linear prediction analysis, relative spectral analysis, among many other things.
And our second guest is Nelson Morgan, professor in residence emeritus of UC Berkeley and former director of ICSI, where he led its speech group for 25 years. He's led DARPA's EARS program and co-invented the relative spectral raster technique, which is a cool name for making a lot of jokes with later on, correct?
Yes. Today, we've invited them to talk about their experiences with mentoring, their own career, and learnings from it, aspects of research, and getting to know them in the process.
So, since it's hard to introduce you, it would be much better if you would introduce yourselves. And we'll start with Hynek.
Okay, well, I'm Hynek Hermansky, and I have to correct the information. I'm not the founder of CLSP. There was Fred Jelinek. I inherited it sometimes in 1912, and I was heading it for about 12 years. And now I'm back in Czechia, and I became emeritus at Johns Hopkins, and now I'm in Brno, Czech Republic, as a research professor at the Brno University of Technology. Should I say something more, or should I start when I was born?
Oh no, that's fine.
Where did I go to kindergarten?
We will get to that later.
Okay.
Morgan, would you like to introduce yourself?
Sure. Yes, I'm Nelson Morgan, and I have been called by most people Morgan for the last 55 years. My career has mostly been in signal processing and machine learning, and I've worked on a lot of different things. I'd say that the periods of my life that were most productive were when I was partnered with someone else who had complementary skills. So one of those was with a brain scientist named Alan Gabbins, with whom I worked on processing signals from the brain. And then the two related to speech were with Hynek Hermansky here. We worked together on Rasta and on other sort of perceptually related signal processing things, and with Hervé Bourlard, with whom I worked on statistical understandings of neural networks, especially in combination with hidden Markov models for what we called hybrid systems. So that's what I worked on for the longest time, and I've been retired for the last 8 years, I think, and have mostly been working on politics, which is another whole story.
Yeah, so welcome to Speech Pitch, Hynek Morgan. I would like to say why we invited you, because I've been in the speech community for a long time, since the 90s. The two of you, my role model. First things I remember joining the speech community, going to an inner speech and noticing that the speech community is so open to new people coming in. There were no hierarchies. It was so easy to get to know you. You never took yourself seriously. You were always fun, giving also speeches about taking off T-shirts and all the things you invented. Each invention had an own T-shirt, publishing on failure, and being able to talk about things that went well and also things that didn't go well. And for me, to have you here is something very special, because we can sort of maybe dig into the wisdom of the last decades and have that spirit sort of persistent in a podcast. So you're here today so that we can kind of dig into your wisdom of the last years and find out more about your experiences and your research.
Great. So welcome again, Morgan and Hynek, and let's move to your research focus. So first question which comes to our head is, when we think of you two, why did you choose speech research over other signal processing domains? And what was your process like? How did you find yourself in this field and the research?
Well, I chose speech because I needed a job. Let me be slightly more elaborate on this. I was an audio engineer and I was focused on digital audio. I worked on fixing some of the equipment for the post-production of Godfather Part 2. I was in that kind of world, and then I went back to school and got my degrees, got my PhD, and in the last year I had children by that point, was very concerned about having a job. And so I did all my job search way before my dissertation was done. And I finally got this job with, I guess I won't say the company, but it was a prominent entertainment company that was totally using analog, but they were planning on switching to digital. So we agreed that I would go to work for them and set up a digital audio lab. And when I was almost done with my dissertation, a friend called me up and said, I hope you're not affected by all these layoffs at X company. And I said, oh, ha, 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 very funny. And I said, I just talked to the HR person 2 days ago about the benefits and so on, so I'm sure it's fine. So after I hung up, I thought, well, I better check. So I called up and asked for the HR person. They said, I'm sorry, she's no longer with us. And and so then I ended up talking to the VP of engineering, who's the one who'd hired me. And he said, oh, this was 1980. You've heard of this thing called recession. And and so they had to renege on the offer. And so I went to my research advisor and I said, Bob, help me. I got children. I'm graduating. I don't have a job. And he said, oh, there's this lab in the South Bay that needs a speech researcher. I said, Bob, I don't know anything about speech. He said, you'll figure it out. So I was in need of a job. So I went there and I kind of did figure it out. And there's more of the story in terms of meeting the guy later, but I can get back to that later if we want.
Well, I wanted to do many things, like acting and being a folk singer. And also, among the other things, I also was a student of electrical engineering out of necessity because I didn't want to go to the army at the time. So I decided to study. And in the process, I was working also about the machine which was visualizing speech for deaf people. And I couldn't figure out why it is good or what is not interesting about that, but I did that. Of course, my ambition was at the end to be audio engineers, just like Morgan. And I was even talking to radio station in Brno, and I was talking to theater in Brno. But then I decided to hang around for a little bit longer with the university, not having a job. So they offered me 1 month and 3 months and sort of temporary things. And I was working on this machine for displaying speech based on zero crossings. But then I offered a scholarship to Japan, and I had a choice between, I was thinking maybe I do electronic music, which I was also interested in. That's what my master's thesis were on, and speech. And I saw the speech is more serious than music, so I said, I want to do speech. And I got to the lab of Hiroya Fujisaki in Japan, and there was no way out anymore because, once you are with Fujisaki, basically, you have no time anymore for acting and playing music or anything. I had to, and I started liking it. So I seriously started doing science really when I was in Japan. Back in Brno, I wasn't all that serious. Basically, I was doing all kinds of things, but I wouldn't call myself speech researcher. But after that, it was 1980, and since then I call myself speech researcher, and I guess I stayed with that because, for one, I actually like speech. The second thing is that more I was doing it, more I realized that less I know about other things. So it was easiest to stay with what I was doing. And as I said, actually, I started liking playing to be a scientist. And so I'm doing it, I guess, until now. That's
funny.
how I got in.
So unexpected career moves. So my question now is like when you started looking at these things and you follow intuitions or ideas or you're being creative, did you know the impact you would have on the speech research field, or did you sort of like fall into it, or you knew what you were doing all the time and it was one grand plan that you were following?
No, if I may say, my ambition was to write one paper which would be published in a magazine which more than one person reads. And I thought that would be pretty much what I want to do for humankind. So no, I had no idea that I would do anything which would have any impact whatsoever. As I said, my ambition was to write one paper not just in the conference, but in a serious magazine. So I succeeded in that. But everything else is kind of extra, I guess. People discover that what we were doing was useful. Grateful for that, but I didn't expect that, no.
What about Morgan? Did you?
So I was always driven by impulse and curiosity. It always. And there was a point when particularly in the funding agencies, there was a really negative perspective on what they were calling curiosity-driven research. You shouldn't do curiosity-driven research, they said. It was supposed to be, you have an end goal, you have something you're trying to achieve, you're trying to, help humanity in some way, or help the military drop better bombs or whatever. And you're supposed to have an end goal, and that's supposed to drive you. And I just maybe it was never had the self-control or whatever. I was just always driven by the curiosity. And then after we had figured something out, like when I was working with Hynek and we did this Rasta thing, I went, wow, that would really be cool. That would really be useful, because right now we talk into a microphone that's different than the microphone things were recorded on for training, and it doesn't work. And Hynek did great experiments on that when he was working for a phone company. It was just, it fell apart entirely, and that was really impressive to me. So that was, yeah, I guess I was partly driven by that, by how bad something was that we wanted to make better. But that was something that piqued my curiosity. Why is it so bad? And that was always my motivation, other than having a job. Yeah.
Can I ask a non-politically incorrect question? Were you able to sort of fake that you were having a grand goal while you were doing a curiosity thing?
I got better at it over time. Yeah, I mean, when I was heading the International Computer Science Institute, I had to deal with a board, and they wanted 5-year plans, and they didn't appreciate it when I played Soviet marching music to accompany the the notion of a 5-year plan. But yes, I got better at it. I think initially I didn't know how to do that, but fortunately I met other people who also were curious about things, and that made it. And also, fortunately, I was in one situation after another where this was tolerated.
Yeah, I would say the same. I mean, but I don't think I ever faked it, or I had to. Of course, I almost got fired from telephone company because I didn't know how to say that what I'm doing is useful, though I was even convinced that it is. But the people who were listening, I don't think that they were easy to convince at the time. But when I think about my life, I think I was extremely lucky that I never had to really fake it. That my positions were such that, I was changing jobs quite often, actually, every 5 years until OGI, where I served double duty, and then Hopkins, where I almost had the triple duty. But other than that, after 5 years, I guess I had to leave, and I had to find something else, because people get sort of fed up with me. But I was lucky that for these 5 years, which I was working for different organizations, I could do it. And I never had to fake it too much, that I'm doing anything useful. Though deep in my heart, I was convinced that what I'm doing is useful. But sometimes bosses are difficult to convince. That's true. Typically, bosses very often want you to do what they are interested in. And of course, this is not what I was interested in. So it wasn't the best political strategy for life, but I managed, and I'm almost 80 and I'm still alive. And surprisingly, I still have some money in the bank. So
Yeah, I just to amend mine, I think, not give the wrong impression, I think I was pretty lucky too. And I also, like Hynek, I switched jobs a fair amount before I got to ICSI. And yeah, usually it was things were headed in a different direction than I was interested in, and so I would switch jobs. But at ICSI, I had pretty much complete freedom, except For me, I guess the point where I did have to fake it a little, or I don't know if faking is really quite the right word. That's more pejorative than I'm really thinking, is in grant proposals. I mean, in grant proposals, you had to make clear, if there was a particular goal of the project or program, I mean, that you were applying for money from, you have to make clear why it's what you're doing is relevant for that. So I don't know if that's really faking it. It's just extending your thinking beyond what your immediate impetus is for doing it to what would be of interest to someone else. So yeah, I guess it wasn't really faking it. It was just trying to understand what the organization, or in the case of my board later, what they are interested in, and how to make clear to them that what I was interested in would also be of interest to them.
Yeah, so there I was lucky that I was with Morgan, because he was writing proposals and I was just writing whatever I wanted to do. And he somehow managed to smuggle it in. And whatever we did, we also managed to declare it as a part of the goal, fulfilling the goals which we promised to do. But I'm thinking about it secretly. I don't think I ever wrote a serious proposal except for one, which was to European Commission. But there I said what I wanted to do, really. I wanted to recognize things which people don't expect. And I was just lucky that reviewers thought that it was a useful thing to do.
Yeah.
But so I didn't fake it even then. And that was my biggest proposal at the time, I guess. It was a large joint integrated project, European project. But we were doing what I wanted to do. We had to sometimes convince our reviewers that what we are doing is useful. I remember one of the reviewers, whose name will remain unspoken, he wasn't convinced initially what we wanted to do that is good for anything. But at the end, I think we convinced everybody reasonably that we didn't end up in a jail and we didn't end up returning money to European Commission, and everything went okay. But other than that, yeah, I always had people who were backing me up, I guess. I was lucky in that way. Playing a little idiot is sometimes useful.
So I have an anecdote that might be interesting on this topic. So there was a U.S. government agency at one point in the early 90s that was offering up a pretty large sum of money for people to develop a connectionist neural supercomputer. It was the idea is to build something that would be really good for doing neural networks. And what we had found at ICSI at the time was that just doing something that implements the basic equations, update equations and so on of neural networks was not enough, because eventually you had to do something, you had to do some conditionals or some branches or something like that. So you need to do some general stuff here and there too. So what we sent in was what we really thought would be the best thing, which would be a programmable supercomputer that had special capabilities for matrix computations and so on. So this was a very competitive thing. All the big universities were competing. It was ICSI plus Berkeley applying for this. And we won the competition. We got the grant. So then we had a meeting of all the people who had submitted proposals. There was only one. It was only one winner. And the guy from the government got up and gave his vision of what a neural supercomputer should look like. It had nothing to do with anything that we had. It was all analog, and it had synapses firing, and it had, it was very, very biological. So after he was done, someone raised his hand and said, "But if that's what you wanted, why did you give it to Berkeley? They're just doing digital stuff." And he said, "Well, they had the best proposal." And so that was a case where we just put in what we thought was the best thing to do, and it actually won. Not that it, would in all circumstances. Probably in most circumstances it wouldn't. We were just lucky, I think, that the guy was honest.
So, Morgan and Hynek, when you talk about like pursuing projects or research work, is there some criteria that you have that, okay, this is the criteria that I choose to dedicate certain amount of time and effort in pursuing this research area or a project? How do you choose your projects? Because you mentioned that you like to pursue curiosity or curious about a lot of things. So how do you decide maybe this might be worth the effort and something else might not be?
I think it's really 100% curiosity. I hate to say that, but it is like sort of, if there is a problem, typically you start with a problem. I mean, like a problem with the microphones or something, you start wondering, how you can approach it and would this work? But you go by being curious. I hate to say it. I know it's been said so many times. People even quote Albert Einstein on that, but it's true. I mean, it works because you are curious if this is going to work, and if it doesn't work, why it doesn't work, or if it works, why it works. So this why question basically is there, and I'm not choosing approaches like looking at the papers or looking what other people are doing and thinking, can I do the same thing a little bit better or something? Not really. No, it is a curiosity, I guess. And it is, and almost trying at any cost to be slightly different than what is being done. And that I learned over a period of my life. I've heard the same thing from Fred Jelinek, who was always saying, if you are choosing what to do, pick up something, if you can, pick up something which is important, but on which not many people work on. Because if you follow the trend, but follow the current fad, then you will compete with many, many very good people. But if you pick up some alternative approach, you may be the only one who does it. And if it works, of course, then you may be lucky. You may not even work all that hard. I mean, but so I would say curiosity and then trying to figure out what to do so what other people don't do.
A metaphor just occurred to me that might be relevant. For me, it's an itch that I have to scratch. I could ignore it and say, oh, okay, well, the boss wants me to do that, or the funding agency wants me to do that, but that doesn't get rid of the itch. And so the only thing that will help with the itch is to scratch it. And that's the thing is when you have it as an itch, which you could also just call curiosity, but I mean, I guess the difference you were asking about, you have lots of things you're curious about. You have lots of things you're curious about, but is there something that really bugs you? Something that just goes, why is it that, you just switch the microphone and all of a sudden the thing doesn't work? It sounds pretty much the same to me. Why shouldn't it work? And for the relevance thing, I think I was thinking of when we got into doing work on meetings, on conversational speech during meetings at ICSE, and this was before AMI and AMIDA and so on in Europe. I was interested in our doing conversational speech, but I wanted it to be real conversational speech. And we were working on speech recognition, and I was going on a trip, and people we were discussing with the students and postdocs and I about, well, what would be an application? Everybody's always asking about applications, and what would be an application that would matter? So one of the students said, well, when you're on your trip, what about, a calendar or some sort of agent to help you figure out what to do and so on. And I went, yeah, I guess, but I'm just fine with my computer, keeping track of that, and it's not a driving need or anything like that. And then in discussing it, all of a sudden realized, wait a minute, what did we talk about in this meeting last week? And nobody took really good notes. And I went, wait a minute, we're working on speech. And we just had this whole meeting composed of speech, and nobody knows what we talked about. And so that was that both was something that I think ultimately turns out to be useful, but it also created that itch that, well, wait a minute, why can't we do that? So that and the Rasta story, I mean, same thing, I think.
Right. Thank you for such an honest, interesting answer. On the same note, I also wanted to ask, you said, I'm sure you both have collaborated with a lot of people, and there might be many things you might have picked up from your peers, be it personal or be it technical. So are there any examples that you can give us about any things that you picked up from others, personal or technical, from your peers that still influence your day-to-day life or your research practices?
So I did have a period when I sort of switched briefly for a few years from speech research to brain signals. And the brain scientist I worked with was really, really good at being very, very critical of other research. But the thing is, he wouldn't just take for granted that something, just because somebody said something and it seemed sort of plausible. He would go down to a level of detail that would show, well, maybe there's nothing to this at all because the way they collected their data was like that. And so I think I learned a lot from him. That was a brain scientist named Alan Gevins. And then I think the next big one that I learned from was from Hynek, who continually kept going to, well, how do humans do it? What if, getting back to the microphone example, if we hear it and it sounds the same to us, we don't have any more trouble with one microphone than with another microphone. Why isn't it that way for what we're doing? We must be doing something wrong because people can do it. And I had an interest in perceptual things before that, but that really drilled it into me. And I think I learned a lot from Hynek on that.
Yeah, on the other hand, I learned a lot from, just like Morgan, from neuroscientists, from hearing people in general. I love to hang around them. I love to hang around the psychologists. And recently, actually, neuroscientists too, I discovered that the wetware is more interesting than originally I thought. But since Morgan mentioned that, it's not that I'm hard-headed about doing things the same or similar way as humans do it or as biology is doing it. But the truth is, if you don't know how to get out of the problem, very often what nature does can give you some intuitions. And if you follow it as an engineer, you may succeed. And most of the things which we succeeded, including actually even, I know Morgan may not agree, but even these deep neural nets, I mean, after all, there are certain aspects, people learning more and more, certain aspects in deep neural nets, which actually do resemble some processing which is happening in a neural system. So, I have a great respect for Mother Nature, I guess. I also have a great respect for the fact that Mother Nature tries to figure out the solutions which are efficient and effective. And if we know how to listen to Mother Nature and be open-minded, it can be useful. So, yeah, I learned probably the most from psychophysicists and recently from neuroscientists, not from engineers so much. Though there are exceptions, I have to be careful. But
So it's pretty interesting to come up with these ideas and to understand the nature of interdisciplinary thinking. And you mentioned you're going into nature, you're talking to people who have different backgrounds. And sometimes we go to conferences and we find only people who do one thing. They all get together, talk about one thing. But actually what we want is to talk to people of different kinds of backgrounds so we can spin off more innovations. So the question to you is the million-dollar question, as they say. Where should we be picking the brains now? What interdisciplinary knowledge is so important right now to drive the next innovation forward?
Well, this is a little related in an inverse way to the part where you said I might disagree. So the idea of having multiple layers of complex units like we have in the cerebral cortex certainly has some similarities to the cerebral cortex. However, there are 6 layers to the cerebral cortex, and people are building these things with 100 layers or 1,000 layers. And the neurons themselves in the human brain are actually very complicated. And the neurons that, for the most part, there are some more complex artificial neurons that people use, but for the most part, they're just pretty simple. So it's a little different, but regardless of that, I think that, and take this with many grains of salt because I actually haven't worked in speech for like a decade, but I've been in this political world. But it seems to me that everyone is so much in awe, myself included, how much these deep nets can do, that it kind of leaves an open question of what else is there? Is there really nothing else? Is there nothing else that we need to do? And yet, although again the performance is really impressive, especially for a generation, but even for recognition, I mean, I do use it sometimes. But I would say that it still has some of the same problems. And so I think the big challenge is to figure out, as honestly as we can, are we really done with other parts of, say, for speech recognition in particular, are we done with other parts of the solution set, or is it really just a question of further refining the large neural nets? And Hynek, I always used to have the position. I think I can tell me where I'm wrong here, but I think we both, for many years, sort of held that it was important to do other processing in addition. And there's been a lot of work for end-to-end systems that just ignore that entirely. And so I think this is a question that has to be approached honestly and without any more bias than you can't help, to see if there is something else to be done. And if there are other things to be done, there's a whole body of literature of people trying different things that could be gone back to and thought about.
Absolutely, we are not done. I mean, there's no question. And you know, what we are seeing now is the machine which can take a lot of data and figure out from these huge amounts of data a little knowledge which is already contained in the neural systems. That fascinates me, actually. People are looking more and more in the properties of these large neural nets, and I hope that this is the right direction to go. And to my big surprise, very often they are finding similarities with processing in biology. You know, just to give a very, very small example, which everybody knows now. So you have an end-to-end system, and you look at the front end of this end-to-end system, where you feed the waveform into it, and you see on the first layers, it does a spectral analysis. This is what the ear of most of the mammals, or actually most of the animals does. It does the spectral analysis. So this is fascinating. Even when you are not asking for that, it's coming from the data. Recently, I discovered that people are looking in some temporal properties of these deep neural nets, and they are discovered that they are surprisingly similar to temporal processes which you see in the human cortex. And so this is truly amazing, and this is amazing about the large neural nets. They are capable of taking, I don't know how much data, but the huge amounts of data, what is being fed in, and they discover what Mother Nature already discovered millennia earlier, right? Or long time ago, actually, millions of years ago. So in that way, this is interesting, and I don't think you would see it in a single layer neural net. That was indeed just interesting way of training a classifier. But these deep neural nets train on all the data which you can get hands on. They can start doing interesting things. Maybe I'm wrong, but that's what I'm seeing.
But Hynek, I have to ask you, if it's doing the right thing, once you get, enough layers and so on, thinking in terms of, our students here who, considering what should they work on, why do it then?
Sure, absolutely. Yeah, why don't we do it? Well, that's a good question, Morgan. And maybe this is a good forum to ask this question. If you see that the spectral analysis is good, why don't we start with spectral analysis, period? And as a matter of fact, most of smart engineers do. I mean,
What I was asking is, why do research on the front end if this is already making, just by learning, a really good front end?
Oh, to me, Morgan, part of the research really is to ask the data in a smart way. What is it that data are suggesting me? And if they suggest spectral analysis, just to give a stupid example, I know that this is something which we should be doing. If it suggests raster-like filtering, which it does, well, why don't we do it? Yeah, sure. I mean, once we discover that this is good, let's just do it and don't even bother training it anymore. anymore. But I maybe this speaks again. My friend Jelinek here, he always believed that the answer is in the data, and actually, most of the scientists would agree that always, if you want to get some answer, you look at the data. And deep neural nets are one way of looking at huge amounts of data. What we learn, we should learn it and use it, not to train over and over and over again. This is stupid. This is a lazy approach to science. But once you learn something, you should be using it.
So we should be studying nature to understand how to train deep neural networks. And then we should be studying deep neural networks to understand what the data is telling us. And on the third leg, we should understand the data by ourselves, so that maybe even topic knowledge is still informing how we do deep neural networks. So we have this triangle thing of nature, deep neural networks.
But let me just say what I was trying to get at, because I think we're not quite there yet. If I were still doing speech research, which I'm not, just to be clear, if I was still doing speech research after being out of it for at least 8 years, I guess, I would want to know, where does the current technology, even with deep neural nets, fail? Where does it fail? I mean, I have, just as an individual who is, uses it sometimes with my phone, it's amazingly good, but sometimes it fails. And I would want to know where it failed and why, and why it fails, so that we could come up with solutions. That was where I was going.
I can tell you where it fails, unquestionably. Just give it data which you haven't seen in the training. Seriously. I mean, and it fails. This is a problem with machine learning, which is totally inherent, because it basically learns what is in the training data. If it is not in training data one way or another, it will fail. And it's failing. It's still failing. I mean, yeah, that's for sure. And I think that, I don't want to say that I have the answers, but definitely I'm thinking about it.
What if the machine knows that it's failing because it doesn't know the data? Wouldn't that take us further?
There's one topic which we are working on, which is like, do you know that you are failing, right? I mean, we had this whole workshop in Prague, this Jelinek's workshop, which was dealing, this one group, which I was heading at the time, was dealing with that, which is like, do you know that you know, or do you know that you don't know? This is a essential question which needs to be addressed, and it starts to be addressed slowly. I mean, I'm not saying that people don't work on it, but they don't work on it enough. And certainly, I don't see any clear solutions how to deal with that. We have to get away from this reliance on a training. And this is a problem in machine learning. Sometimes I say that speech recognition is not the problem of machine learning. It's not the problem of training the system. It's a problem of designing the machine which can get out of information without being trained.
Okay, so what if the AI knows, okay, I don't know this, but I'm talking to all these people around the world. I know who could be knowing it. So here you have a message coming to Hynek and saying, okay, the AI, I have a gap here. And I know that your brain can figure it out. Could you help me with this? And then we have symbiosis or cooperation between AI and humans. What do you think about that?
I don't know if I heard the answer for you, but I really think that relying on the machine learning for getting information out of sensory signals is not exactly the right approach to a problem.
So I guess there's two things. So one is, and again, being out of it for 8 years and just having experience, my main experience with speech recognition is as an individual using it occasionally. So the first is the thing I said before, which is, where is it failing, so that to maybe spike our curiosity about how to fix it. But the second is, even if it worked, you collect all the data in the world and you have the best, most perfect machine learning techniques, so that there is no test set that is not included in the training set. You basically have everything there, right? Or essentially that, because you have such a mountain of data. The other factor is, why do you have this enormous machine when you could actually do something in principle much simpler? That matters in terms of electricity, water, some of my current concerns, carbon. And this has been true in many, many engineering fields. Hynek knows very well that people put together something that's maybe very complicated because it's just the process of how they got there. But then once they stand back from it and realize, oh, that's what's happening, much as Hynek was saying, oh, it's doing spectral analysis, then you can reduce it to something much smaller. I mean, I know there's been some work strictly in machine learning, and this is old news because it was when I was still doing some of this stuff, where people would train a huge deep net, and then they would generate targets from it, which then would be trained on by a smaller net, one with just maybe one or two hidden layers, and you get something that works about the same. So the deep net was very, very useful for doing the learning part. But once you sort of had that figured out, once you had a complex function that actually did the transformation between the input and output, you could actually represent that pretty well in something that was, quite a bit smaller. So that's just in machine learning. But then there's also the sort of signal aspects of it that Hynek's talking about. So I think there are these two pieces. There's spiking the curiosity about what is it that isn't working and how should we fix it, and doing something in a less gross way, huge dumb neural net, and still doing it.
Mm-hmm. Yeah, but maybe I don't want to do what I'm doing, which is like I'm almost repeating a talk which I gave a couple of years ago at NIPS, which was titled, "If You Can Beat Them, Join Them," which was basically suggesting what I was saying, which is like, yeah, we have a very interesting technology which can eat a lot of data, but it's a dumb way of wasting the data on training the machine. The right way of using the data is to learn ourselves. But one way to do it is to look at the trained neural net and see what the net is doing. And if the net is doing it based on the data, then you are pretty certain that this particular property actually is important. Because problem with biology is that it's pretty complicated and has many, many more things, maybe even more important than recognizing speech. How do I know which part of the machinery which we have in biology is used for recognizing speech and which is there for much more important things like recognizing what may eat me or whatever the biology is mostly interested in. Where is my friend and what can I eat? So what I'm saying is that I have a deep respect for the data, and I think that neural nets are actually a very useful way of looking at the data and learning from the data. But we should be learning from the neural nets. We shouldn't be just ending up with training the neural net and using it. This is a waste of data, especially if you train it once and then you train it again, and learning is pretty much the same thing. But I don't know if I'm becoming a little bit too involved here, but there is a number of things which neural nets are not doing. A lot of the things are based on the current paradigm which we use in machine learning, where we train the machine and then we freeze it and we use it. We keep forgetting that biology is learning all the time. As we speak right now to each other, we are learning, right? Machines still are not very good in that. There's not many machines which learn during inference. So those are the things which we should be thinking about, since Kai was asking about what is it that people should be working on. Yeah, I think that they should be questioning the basic approach, recognizing speech based on machine learning.
Yeah, and let's not forget carbon production, which actually is
carbon
related.
production, Morgan, there I didn't want to touch. But carbon production is the problem with the digital technology, because you are working with semiconductors which are being saturated. And those of us who were trained in analog world, which maybe you and me were, you remember that original approach was that you don't go into saturation, you try to work on linear part of the response, meaning that the transistor is not saturated entirely, but it's essentially the analog world, which maybe revisited. I don't know. I mean, some people would strongly disagree. I guess Morgan would be the first one. But I think that carbon footprint is a problem of digital technology.
No, I don't disagree. And in fact, I want to argue against myself, which is something that I love doing. So I've been very concerned about the carbon footprint of training and inference as well. That's less, but still in huge neural nets. By the way, over 30 years ago, I wrote a paper called, I can't remember if Hynek was on it or not. It was Big Dumb Neural Nets. And
I wasn't, but I enjoyed the paper.
yeah. And at the time, the big dumb neural nets were 1 million parameters, which was more than anybody else was using at the time, because we built some hardware technology to speed it up. Well, now they go like 1 trillion. I mean, it's 1 million times as big. So I've been worried about the carbon footprint of that. And then I got some feedback that it is something to worry about, but here's a bit. Doing one query and getting a response back from ChatGPT essentially is equivalent to releasing a gram of carbon into the atmosphere. Watching an hour of Netflix is equivalent to putting 100 grams into the atmosphere. So as much as I am concerned about it, I agree with Hynek that it's probably fundamental to the whole technology and isn't just dumb neural nets. But just the same, there are wastes that are there. There's here in Arizona, they're building TSMC, the Taiwan semiconductor manufacturing company, is building some big fabrication lines. And this is a desert here. And they're going to use tons of water, tons of electricity, which will have to be generated with all of the disincentives being put in place by the current federal administration and by some of the people in the state. There's fewer incentives to use solar. And so it's probably going to mean just for the electricity to operate these fabrication facilities is going to be increasing the carbon going into the atmosphere. So so it's a huge problem all around, and it isn't just deep neural nets, but those fabrication lines. The reason why they have to keep building more and more right now is because of production of all these chips by NVIDIA and others for training and running large neural nets. That's actually the biggest single source of need for these production facilities.
Well, so here we have this thing, I mean, which you were suggesting, let's use all the data in the world to train our big machine learning neural net. It's not going to happen. I mean, and it is a dumb way of working.
I agree.
Because, there we should be looking at the biology, look at the child which learns from the mother, and understands the anchor very well, even when the anchor, this is for the first time in child life. It doesn't need these huge amounts of data to train, but is learning all the time. I mean, biology is learning permanently, not speaking about learning over the evolution, but even over lifetime, we are learning all the time.
Yeah,
I mean, you're learning my stupid, strange accent, and if somebody else comes, you learn another accent without being exposed to that necessarily, because you learn during inference.
Yeah, I completely agree, right? I was talking about using all the data in the world as a model, as a kind of metaphor for what they're currently doing, right? If you have trillions of hours from the web or whatever, it still doesn't cover it, because if you look at the sort of outer product of all the possible sources of variation that happen in real life, the accent you mentioned, the different environment, and so on, it is way, way more than all of the data on the internet.
Yes.
Yeah, is many orders of magnitude more. So it is ultimately an incomplete strategy. It's interesting. It's amazing what it can do. There are things that can be learned from it, but I'm the passion with which you said is exactly why I was attracted to working with you in the first place.
Thank you, Morgan. Yeah, but I guess I am passionate about this. Yeah.
Something that brings us a little bit to the next topic area, which is that of mentoring, is listening to you. Of course, now my brain is spinning because I have lots of ideas for what I would like to do, which I don't have time for. But we have lots of students listening who do have the time. However, how can normal people, like an average student, talk to heroes like you, not be scared? Because maybe they want to ask exactly the kinds of questions after listening to this podcast. They have some ideas and they want to pick your brain more. Like, how do you see mentoring and how easy is it to approach you? And then I think Priyanshi has lots of other questions that from student point of view for you.
So let me start with that. And I just want to say that I had the wonderful experience, and I think Hynek had this too, of having students who listened to me respectfully and then went off and ignored what I told them.
Exactly.
And then came back and said, well, Professor, I understand where you came from with this, but it was not right. I just did this experiment, and then I'd look into it. And sometimes they did something wrong and I would correct them and I was vindicated my original thing. But sometimes, not that infrequently, they showed me something. I mean, it's kind of a cliche, teachers learn from their students, but in many cases, it's really, really true. So I think students, if they can remember that, yeah, there are things to be learned from people who have been working in the field for a long time. I have to hope that that's true. But people who approach it with a fresh eyes and fresh mind can often see things that people who have been working on stuff for a long time do not see. And they should follow that itch. They should follow that curiosity. And even if they end up vindicating what the senior person said, they've seen it for themselves. And that's a very different feeling.
Yeah, 100% agree. I don't think that my students are afraid of telling me that I'm stupid. And I don't mind hearing it at all. And I actually encourage that because I don't know, it may be more difficult, Guy, if you go to a conference and there are students who are maybe coming from different countries where they are not used to question their professors. But I would encourage them not to be afraid. Basically, I don't mind at all. If somebody comes to me and tells me that I'm wrong, what I'm saying is incorrect. And of course, it's probably very often true. And even during my lectures, I encourage people to tell me when I'm wrong and when they don't like what I'm saying. And so I don't consider myself a hero. Let me put it this way. I don't consider myself in any way special except that I'm almost 80 is the only difference. Other than that, my brains are probably not as good as they used to be. And my knowledge is not as current as people or knowledge of my students. So they shouldn't be really afraid. And they should be honest. If they don't agree with something or if they have an honest question, they should ask the question. I remember myself when I was younger, and of course I had my own heroes until I met them. When I met them, suddenly I discovered that they are totally normal people. You can talk to them in total normal way. They have the same doubts as I used to have. So I was lucky that I met some of my really big heroes whom I only was dreaming about being back in Czechoslovakia. Suddenly they were sitting next to me at the conference, having a beer together, and you discover they are very normal people.
So I'm not as incredibly old as Hynek. I'm only 76. But
Oh.
Yeah. I mean, one thing I said that I do think it's good to be respectful to not just to older people, but to anybody. It isn't really a distinction between the quote unquote heroes and novices. Just, it's especially as I do in this whole political world now, and I'm seeing all of the completely nasty behavior from certain quarters. I appreciate more than ever people just being civil to one another. And then, it's true for teacher to student and student to teacher. Everybody should just be civil with each other, and then they can disagree, and then you can run experiments. This is a field where it's wonderful because, you can try something out and you can run an experiment and you can find out. The one caveat to that I want to add is when you try something new, the first time you try it, it will almost never work. So the other thing is you should also never be discouraged because the first time you try it, it doesn't work, because that's kind of the rule. But anyway, I think respectfulness is good from both sides, but disagreeing is when you feel it, when you think it, you should follow up on it.
Well, I don't mean that I want to have students calling me, Hynek, you are totally stupid. No, but showing it to me, I don't mind. I mean, this maybe. So,
Right.
so respectfulness, yes. I mean, I agree. We need a little bit more civic behavior in the society. That I agree. And it doesn't get you anywhere if you are really jerk. But if you honestly disagree with something and you have a reason to disagree and you bring it up, nobody who is reasonable gets upset about it. That's what I think. I mean, I certainly don't. And I agree with Morgan also. I mean, things never work. I mean, never got into that. But anytime you try something for the first time, it doesn't work by definition. Because if you do something new, you have to do maybe 100 things right. And only one thing which is wrong, things that doesn't work, right? I mean, so that's very easy to get the wrong, bad result. But, well, bad, unexpected result. But somebody said, I don't remember who it was. I wish it was me, but it wasn't. Which is like, if you get what you expected, you just did the work. If you get what you didn't expect, you might have made a discovery. So if you run an experiment and you think your hypothesis is, I will do this and it's going to work better, and it doesn't work better, maybe you made a discovery. Maybe you discovered something which actually can be very nicely used in different circumstances. So.
Yeah, Hynek, do you remember when we tried the Journal of Negative Results? I forget if it was called that. Yeah.
Yes.
So we had an online journal that we tried to do because we were annoyed with the fact that everybody who publishes a paper was successful. They did this and worked wonderfully, and they reduced word error rates by 10% or whatever. And we thought, it doesn't happen to people we know. I mean, people we know try stuff out that doesn't work, So what about the 10 experiments they did before the 11th one that worked? I mean, was there anything to be learned from that? So we wrote a paper together, I think with Hervé, maybe, and I can't remember.
Yes.
And we pointed out how important this would be. And we used that as the supposed initial input into this wonderful journal, which then nobody submitted anything to.
Yeah.
It turned out people who wanted to get research grants and so on didn't want to advertise that they were failing so often, which everyone does.
That was good. Yeah, it was interesting. I still stand behind this paper, I must say.
Yeah.
On the note of trying different things and failing, what is your stance on the whole idea of like moving fast and breaking things? Basically, do you think that people should focus on like iterating faster, or is there more like deliberate approach of like moving slowly and doing research and taking time? Should people focus on iterating or other aspect?
So you sort of yes to both. I mean, it never hurts to think. I think thinking is good and just iterating. I mean, there are times when you're trying to do something very simple, like you're trying to find a number between 3 and 4 that would be the best for some engineering result. And so you put out, 3.1, 3.2, 3.3. That's fine because the thought ahead of time, it's in that range. It's kind of an engineering thing. You want to find the answer. But as far as trying new things, and it's different if you're public facing, right? If you're releasing something that people are going to use and are actually going to need to be functioning well. I think there are real problems with the move fast and break things idea. We definitely saw this in the US government this year. But I think the idea of thinking and then trying the next experiment after you've thought doesn't mean that you're slow, but just put some thought behind it. Don't just routinely throw in a list of random things that you want to do. That would be my thought. Hynek?
I agree with Morgan. Both is important. I think that, but to be a little bit bold and a little bit brave and a little bit out of the main road is maybe useful sometimes, maybe not all the time. And sometimes I also say it may get you far away, but may also get you fired. So you have to be a little bit careful. I mean, I think break things, I believe that came from Facebook, right? So Facebook said it after they already had quite a lot of money in the bank. So maybe they can afford it, but just to be crazy and just show how brave you are, it's also not the right way to go. No, but staying in a mainstream and trying to improve things slowly, it's not exactly my style. Yeah. So
those are fair things. And coming back to how Kay mentioned about students approaching you and basically mentoring in general, given the fact that you've spent so much time in researching and teaching, are there any things, or if any, that you like about mentoring students and you'd like to share with us?
Well, sure. I mean, having a good students is a real gift. And Morgan already said that we are learning from very good students. I have to be entirely honest, I can't do anything without the students anymore. I tried quite recently, I spent a year at Google Tokyo without the students, and it was really depressing. I was talking, but no work done, really, because I got so much used to having students around. So, absolutely, I mean, without students, at least I couldn't do anything. And also, I remember the big difference between me being alone working for a telephone company and suddenly joining OGI. Okay, you may remember that. Suddenly I had the students around. I felt I'm 100 times more productive immediately. So, students are fantastic
So,
if they are good. If they are
yeah.
not good, it can be a big pain. That's something which I, of course, always end with Morgan being at Berkeley, because the Berkeley students are by definition great. If you are somewhere else, including a number of other universities I was with, you may get a good students, you may get not so good students. Not so good student, it's a lot of work. Of course, you want to get them through. You try your best. You get them through. You don't feel 100% good about it. And it's a lot of work. If you have a great student, boy, it's a gift.
Yeah, I would say that the Berkeley students I had did range from good to incredible.
Yeah,
That's
I
certainly
know.
true. That's certainly true. I mean, one of the one of the students who listened to me least is now a VP at DeepMind, and uh, no, he wasn't disrespectful. He just had his own mind, and But anyway, yeah, I agree with all that, and I'd say that for my career, I had about a decade of being a researcher post PhD where I didn't have any students and I was doing, everything myself, but I was still current with the technology, right? So I could do it myself. I could do all the coding and so on. As I got older and the technology kept moving and I got more into mentoring and teaching and so on, I got further from sitting down there. And this isn't true for everybody. I mean, I know people who are our age or approaching our age who just stayed with it and continued to do all kinds of coding and really keyboard work themselves. But it's harder. And I remember at one point this was more again in the political work, but we were putting together an application and we only had this programmer part time. And I thought, well, I used to program a lot, I'll help. And so, is there a place in this project that I could fit into that I could do some of it? And so he says, oh, yeah, no problem. And he started typing, and windows were flashing, and there was, there was, this was some sort of modern web-based thing where there were routines that were calling other libraries, that were calling other libraries, that were everybody who worked in that particular aspect of software knew about. And it was just like watching a light show of some sort. I had no idea. And I just said, you know what, I just let you do your thing. So there is this whole aspect of competence and age and all of that. And then aside from that, there is just the factor that these are other, when you get good students, and I was fortunate in that, as Hynek said, that's just a real force multiplier, and not just because they're doing my bidding, but often because they're not,
Yeah.
and
Yeah.
and it's not just the thing we were talking about before of them saying, well, you're wrong, professor, it's just that they are doing a bunch of things and they have the curiosity bug and they're doing things, and all of a sudden, one student in the middle of doing something else related to speech got tired with how slow things were going, and so they did a bunch of low-level routines that were transferable to other machines that would do certain kinds of things really, really quickly, and that sort of spread out, and lots of universities were taking them up, and this whole thing happened with like 5% of this was Jeff Bilms, who later became a professor at the University of Washington, and Krista Isanovich, who was one of the founders of Sci5, which is this organization for the RISC-V chip. They were students there, and they just, did this whole other thing on the side. I think it was called FIPAC libraries, PHIPAC or something. Anyway, and yeah, so that was sort of a side thing. But even within the research area that I was doing, they will do things that I didn't ask for. And that sort of just really increases the possibilities for creativity for everybody in the group, not just me.
You mentioned that these students that you work with or people that you work with, some of them themselves have the curiosity bug and they don't necessarily do things only when asked. They sometimes try to do things on the side, taking their own initiative. So, like a natural follow up question based on that could be, are there any patterns that you see apart from these, or maybe could be the same, in student learning capabilities that make these students successful? Or what is a good student? What characterizes a good student, since you both mentioned?
Well, again, I mean, maybe I should just say something. I think that a good student is the one who is curious. Again and again, I repeat the same thing. It's not the knowledge. Knowledge always comes. You have to be interested in the things, and you have to be curious about the things. That's a good student. Even if the student is slower than the other students, as long as they are honestly interested in the problem, those are the good students. And the good students are also the ones who don't do exactly what you ask them to do. As a matter of fact, typically the best students are the ones who don't do what you ask them to do. Maybe you have heard it before, but when I think about it, that's the good student. Good student is, as Morgan said, who come with things which you never even thought about.
Yeah, I was just going to say, so another way of saying it maybe is students who are personally driven. You know, they have their own, well, I've got to pursue that. I know he said to go here, but I can't get it out of my mind that what about that? And I want to give a couple edge cases too, besides the just sort of imagining these students that have all of these great properties. There was the occasional student that I got at Berkeley because, I mean, Hynek was saying all students who come to Berkeley are great, but you know that's I appreciate that, but it's a slight exaggeration. I mean, there are students who make it into Berkeley because they have fantastic test scores and fantastic grades, but that's what they've learned to do. They've just learned to do that, and they don't have that bug. They don't have that feeling of being driven to get something. And I have had the occasional student who sort of didn't make it in my group. It was unusual, but it did happen, who was super qualified on paper, but they didn't have that. Then there's a third category. These are students who come from a different kind of background, whether it was a different country, as Hynek said, or maybe it was just their parents, their upbringing with their parents, that they were driven to do whatever they were told and do it very, very well. And the reason I'm making that a third category is because some of those students acclimated and they went, oh, if I'm going to do very, very well, I'm supposed to actually do what I want.
Yeah.
and it's an adjustment, but I've had some of those who turned out to be very good. They might not have been the very top. They might have been the very top. The ones who were top are the ones who just couldn't stand from the moment they were there and before. But they were very, very good. These ones who adjusted to the paradigm that they should do what they want and what they care about. That and getting used to my humor, which because I remember one of my students who was like, I think it was on his first day, and we had a group meeting, and I started saying, we really want to understand the brain better. So what we're going to do is have some of the students have big spikes put into the top of their head so that we can monitor their neural patterns. And we'll start putting the spikes in tomorrow. And the new guy was he's a professor now, and I think he probably does not do that to his students.
But he might say he would. I have a question regarding students. So when I mean, back in the days when we submitted papers and we got rejected, how do you know that the rejection isn't personal and it's not the end of the world? And even 3 rejections in a row is not the end of the world. And it's not the fault of the reviewers either, but life continues and you will get accepted one day. How do you deal with this rejection? What do you tell your students? Not that yours get rejected. I don't know if you even know this feeling.
You better know. I mean, you are not relying on the reviewers to tell you if your work is good or not. I mean, that's a basic things I always tell my students first. Don't write the paper for the reviewers, because very often they say, I did that because I think reviewers may like it. This is the most stupid sentence I could ever hear from a student. I really try to discourage them or scold them immediately. If the paper gets rejected, I tell them, you have to remember that the reviews are done by people like you and me. I mean, that doesn't mean that the paper is wrong. If you don't feel good about the paper, then it's a bad paper. But if you feel good about the paper, come on, I mean, there always will be another opportunity to publish it somewhere else.
Yeah.
If you are happy with the paper and it doesn't get accepted, that's all right. I mean, that's really I should say the scene from my life. I was once technical chair of one of the ICASPs. I had to reject my own paper because the reviewer said it wasn't very good. So I wrote a letter to myself, dear Professor Hermansky, among many other good such saying, blah, 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 your paper wasn't accepted. But while I was already rejecting it, it was accepted into a magazine, the same paper. That essentially happens all the time.
Yeah.
People shouldn't get upset if the paper gets rejected, because reviews are done very quickly nowadays, very sloppily very often, and reviewers are just people like you and me. That's all what I can say.
So let me add 2 things. One, a slight addition to that, and the other, an anecdote. Okay, so the slight addition is that it is also true that sometimes reviewers say something useful for you, right? So you shouldn't just reject it because they rejected you. You should actually go through and see what
That's important thing.
what is there of value in what they've said. Not like, what do I need to change in order to make other people happy, but what is it that I did that was maybe weak and should be strengthened? Should I have had less of a biased data sample, or whatever, something like that. The second thing is an anecdote. So in the late 80s, early 90s, when there was a wave of interest in neural networks, we were publishing lots of papers, and we were getting papers published in very, very tight acceptance number conferences and publications, right? I mean, we were doing really, really well. We were really happy about that. Then there was this one conference, which I won't name, which also sprung up in the interest in neural networks, and they had a 95% acceptance rate. I mean, we were getting accepted in things with a 20% acceptance rate, but there was a 95% acceptance rate. And we submitted a paper because we were doing, as I was saying before, digital implementations of neural networks. And so we wrote a paper about neural network software. And we were rejected by this meeting that had 95% acceptance rate. So I just thought it was hysterical. I mean, because I was so confident because we were getting accepted in these other places. I was pretty confident that what we were doing was reasonable, at least. And so I looked into it, tried to figure out why it was, and I don't think it was professional jealousy or bad or anything like that. From the reviews, I got the clear impression they did not understand why neural network software was important or relevant at all. If it was about hardware, which was generally considered to be analog at that point, or if it was about algorithms, fine. But software, who cares about software for neural nets? So anyway, that was just a fun case of being rejected, where it was easy to laugh it off. But if you're new to publishing, and you submit something and it gets rejected, it can be much harder for people. I understand that. But like Hynek says, you know, see what you can learn from any reviews, but otherwise stick to your guns and publish what you think is
Okay.
good and
Okay, so
important.
it's basically if you get rejected, it's because you're ahead of your time.
That might be,
Could be.
without joking. No, absolutely. That's very often the case. I mean, you know, our friend Jan LeCun says he remembers the days when the paper wasn't accepted when it was about neural nets. Now it's not accepted because it is not about the neural nets. And I can give you the example. We were working on some software for telecommunication industry, which was doing very well. Morgan, you remember which one? And we didn't win, we didn't get in. And I was then asking people who actually were deciding why to take one solution, not the other. And they said, you know, we didn't believe that your approach was sound because there were neural nets there in the software. And well, you know, that was happening. I mean, really, there were the days when people didn't take neural nets seriously. They thought that if it is not HMM, it can't be good, right?
Yeah, and I was general chair for interspeech in 2016, and I remember just because being general chair, you're concerned about do you have enough space in such and such room for such and such session, and everybody was in the neural net speech session by 2016, and the poor guy talking in the language processing for speech synthesis or something, had like 5 people sitting there. And we had people coming out the doors in the neural net one. Yeah, and as Hynek said, a decade before that, it would.
I remember that very well, yeah.
Yeah, opposite.
We also wanted to know what you guys are up to these days. So, could you tell us something about what you guys are doing, what kind of activities you're up to, and what do you do for fun?
Who starts?
Well, I'm always happy to talk about what I'm doing. I was trying to give you an opening, but but sure, I can start. As I said, I think the last time I worked on anything in speech was around 2017, 2018. It was with my last PhD student, and we were part of a research project that was mostly out of Stanford. Former postdoc of mine who at the time was chair of linguistics at Stanford, Dan Jurafsky, and a sociologist there with him were doing a study in which they had the speech from many, many traffic stops where the police were stopping a driver in the city of Oakland. And they were teasing out how Oakland police were speaking to white versus black motorists. And, an example, just a singular example of what they were saying to black motorists that they weren't to white motorists. And when I say they, it isn't all the police, but it was a significant number. They were saying, "Are you on probation?" That's an example. So that was a segue kind of for me to move from doing speech processing, signal processing, machine learning, and so on, to the political work that I do. And I started working on activism in the US, which was important to me then. I was concerned about the impact, particularly concerned about the impact of big money on politics. But then, boy, if you look at it now, the things that are happening in this country, basically it's the onset of fascism, to not put too fine a point on it. And so what I'm doing right now is working, I can't do anything at a national level. So I'm working with other activists within Arizona, which is what's called a swing state, both in electoral college and in other ways. It's something that could go either way, and it's going to be pivotal in future events in the country. And that's a place I can actually have some influence. So I work with candidates and I work on language issues. And I'm also the chair of the Census and Redistricting Committee in the Arizona Democratic Party currently, where we're trying to make redistricting fair because that's what actually sets the playing field, so to speak, to be level if you have fair maps that determine where the district lines are. I guess I fantasized when I started into it that my technical background would come into play in terms of machine processing of map lines and so on. Turns out not to be true at all. It's actually more my management experience because I'm dealing with a committee and then I'm dealing with an upper entity of a state party. So that's what I'm working on now. And there are analogs to what I did before, not so much in terms of the technology, but in terms of being a mentor and dealing with students. Here, I'm working in various capacities, and there are volunteers, some of whom are very young. Some of the very young ones, it's really is analogous. The one candidate I'm helping has a volunteer who's 22 years old, and he's become the campaign manager because he's had like 5-7 years of experience in the political world, including working for Obama. I mean, he's very, very experienced. He's as experienced as I am in the political stuff, and it's a way bigger fraction of his life. So I think that has been pretty important to me. So that's pretty much what I work on. Every now and then technology comes into it. When the redistricting was happening here in 2021, I worked with some former grad students of mine to do quick transcription of a bunch of public meetings because the powers that be in the state were taking a month to come up with the transcriptions. And so we did it in 24 hours. And they were imperfect, but that's making use of it. As far as I'm not really doing speech research anymore. But again, you learn some things about life over time and learn some things about life doing the things that we were doing in science and trying to apply them in a different area that I'm inspired to help with.
Great. Hynek.
Morgan, this is amazing, I must say. I mean, I do things which are much less useful, which is actually I still stick to the research. I mean, maybe not as much, well, in little bit different form. I try to be now more like a professor who actually can do whatever he pleases. And I'm more looking into neuroscience now, as I already mentioned. I'm looking into things which Kyle was, I think, already asking, what is wrong with the current technology? And I can see a number of things which are possibly may be wrong, which definitely are inconsistent with what's happening in extracting information from sensory signals in nature. Namely, I'm looking into feedback connections. This strikes me as interesting that for 100 years, people know that there is typically more connections going from brain to the periphery than connections from periphery to brain. And so that must be for some reason, right? I mean, nature doesn't do anything which is not very efficient. So I kind of feel very strongly that this is something which is being largely neglected, which is feedback connections which are being used during inference for modifying property of the system so that you can do better. And that also goes together with this idea of having a system which knows that it's doing well, or system which doesn't know is doing well. Typically, I don't know what your experience is, but human beings are pretty good in knowing if they know and knowing if they don't know. Systems are not very good in that. So that's what I'm doing, I guess, for fun. Besides, of course, having fun, like right now I'm in Switzerland for 2 months, walking around. We just walk part-time around the Mont Blanc. So, but this is not anything which is useful for the humankind. This is just my own fun. But I guess the research is also for my own fun now. I'm not having such an easy time to get students attracted because I feel like students, at least the students I see now, they are much more interested in making it in the world than we were. When we were young, I thought we mainly wanted to have fun and maybe make some difference. Now the students are more interested in getting a good jobs, and if they see the salaries that people are being paid, maybe be one of those who get a good salary. But so that's what I'm doing. I mean, I would say neuroscience with applications to information extraction from sensory signals. That's what I feel that still there is a lot of space for making some progress.
I still think you have a lot to contribute, even if you're just, walking around and gazing into neuroscience. In the US right now, it's going to be very difficult for people to do any kind of basic or even some of the applied research for the next few years. It's, grants are being cut. Some of them, the ones that were already approved are being impounded. Universities are being attacked. And some faculty at prestigious universities are already leaving the country. So I think if there's good progress to be made in a lot of research areas, much of it will be made outside of the US for the next few years. And after that, it's, even if we are able to get over this period, it's going to take a while to get people back. Well, and people will find they like Switzerland, they like the Czech Republic, they like these other places, right? And if there are language issues, they like, the UK and Australia and so on. So it's going to be hard. So we're depending on you folks, especially you, Priyanti, and Spiretta, and all of your gang to actually, make the progress that is going to be very hard for the students here for the next few years.
That's a really good closing statement to take home. We usually end the podcast with asking you the question from the person that came before you, and then asking you to come up with a question for the next group. So the question from the previous guest is the following: what do you think was a pivotal moment of your career?
For me, it was, I already mentioned that, was very early when I went to Japan and I could work with Hiroya Fujisaki, and that was one very important one. And the other one, I hope that Morgan won't mind, when meeting Morgan, being able to work with him, because I never realized how important it is to have a buddy who basically understands you even without saying anything. And of course, I greatly miss it right now, and I missed it for a number of years. But that was very, very important. If I think about two points in my life. One was what made me a scientist, which was going to Japan. Another one also figuring out how to get fun and making a difference, which was with Morgan.
Well, yeah, like Hynek, I have a few such moments, and one of them is the exact same. that meeting Hynek, I think I won't give his name, but there was a prominent signal processing scientist who was at a conference, and Hynek was standing there, and he saw me coming, and the guy said, "And Hynek, if there's one person I really hate, it's Morgan." And, Hynek can respond better than me because I'm just guessing what was in his head, but I think I think he was unsure of how to take it.
Oh no, I was totally excited. I said, I have to meet this guy.
It was it was a long story, but basically it was somebody who I had thought I was closer to than I really was. So I sent him something on email that was a joke, and he didn't get the joke, and thought I was being insulting to him. So I had to sort of. He was very, very, very senior compared to me, and so I had to sort it out. But anyway, that was when I learned not to just write something in email and send it, but to write it, put it away, especially if it was about something controversial, which it was. Put it away and look at it later or the next day, and then decide whether to send it or to edit it. I learned that from that that experience. But anyway, yeah, meeting Hynek then, that was important to me. The other collaborators I mentioned, meeting Alan, I knew Alan Gevins, but going to work for him, and Hervé Bourlard, some years later. I guess the other event was, other than meeting these important people in my research life, was the point at which I went from being a recording engineer to being a full-time student. which there was a wonderful professor at Berkeley named Andy Neureuther. And by the way, I had never finished my undergraduate. I was at the University of Chicago for a couple years, and then I dropped out. And years later, I hated the fact that I didn't have the technical understanding of the machines I was using as an audio engineer. And so I decided to go back to school, and I was finishing up my undergraduate at Berkeley, and I had an undergraduate advisor, and and he said, you're pretty good at this stuff. Have you thought about coming to graduate school? And I said, well, I would, but I have 3 kids now, and I have to feed them, and I don't know. He said, well, there are these things called fellowships. and and he started to explain to me, and in particular, there's the National Science Foundation Fellowship, an NSF Fellowship. And what I decided I would do is I would write down exactly what I wanted to do. No holds barred, exactly what I wanted to do if I got the fellowship, what research I wanted to do. I had a very clear thing in mind that I wanted to do. And if I got the fellowship, I'd go to grad school. And if I didn't get the fellowship, fine, I'd go back to being an audio engineer. And I got the fellowship. I was able to feed the kids. So that was a very pivotal point in my life. Oh, can I give one more? I'm sorry, there's so many.
Absolutely.
But I told you about half of the story of when I thought I was going to work for this audio company, and then they had the recession, and my advisor steered me into this speech company. Well, many years later, when I was actually heading up ICSI, there was a conference of company heads or nonprofit heads or group, sort of a CEO meeting. And the guy who was the VP of engineering at that company was one of the speakers. And after he spoke, I went up to him and said, hi, I don't know if you remember me, but I'm the guy who you offered this job to and then, pulled back from. And you could see him sort of physically moving himself a little bit from me, like, who's this guy? What is he going to do? Is he going to punch me? And I said, and I wanted to thank you because my current wife, was also in the speech field. And without my having switched from general audio to speech, I would never have met her, and I have a wonderful marriage, so thank you.
Very good. So what I'm getting out of this is that your pivotal moments have to do with humans. Seems like every time it's a person that comes into your life. So that's amazing. Now, do you have a question for the next person, not knowing who it's going to be, that you would like to ask somebody who's going to be on the next podcast?
Well, okay, here's one which calls back to an earlier part of the conversation. Do you think that better and better deep neural networks will solve everything that we have to do in speech? Or are there fundamental things about speech processing that need to be researched beyond that? If so, what are they?
Okay, if I may ask a question, I was thinking about it now. I assume that the podcast is mainly for students. I think for the next person which will be interviewed is something which we didn't talk. We talk about it a little bit, but not enough, which is like, how can we convince students to stop writing papers about what they did and how they did it, and start writing papers about why they did what they did and why they are getting results they are getting. So as opposed to questions what and how, the question why.
That's a
I
good
like
one.
it. Exactly. Okay, so I think we have come to the end of our podcast. Thank you so much. This was very insightful. I'm taking a lot of gold with me. What about you, Priyanshi?
Yeah, I think there were a lot of interesting context and perspective that we got to know about Morgan and Hynek, and we learned a great deal. So thank you so much for joining us today.
Sure.
And thank you for your time.
Okay, well, thank you very much. I really appreciate the opportunity.
Yeah, thanks. This has been fun.
All right. Thanks a lot for listening, and stay tuned for future episodes of Speech Pitch as we might interview your favorite speech researcher next. Don't forget to subscribe wherever you are listening to your podcast, and also follow the ISCA SAC on LinkedIn, where we share our latest news with you.
Speech Pitch by ISCA SAC.